stainless steels, tool steels, porcelain, alumina, zirconia, silicon nitride, silicon carbide, cemented carbide, also known as hard metal, copper, titanium. All these solid metals and ceramics 3D printed very much like plastic using one unique binder toolbox. With Emery Oleochemicals being a long-time supplier of specialty chemicals, optimizing processes by additives is at the heart of our business. This binder toolbox was invented in our labs over 30 years ago for a process called metal injection molding, and the bundle of applications has grown bigger and bigger. Youngest family member is additive manufacturing. How does it work? Metal or ceramic powder is compounded with the binder to form the feedstock. The composition of the binder is tailored to the process that follows. In additive manufacturing, the feedstock can be printed as such using a pellet printer, or can be extruded to a filament to be used in a filament printer. In any case, the part that you print is a so-called green part, which still contains the binder. The green part is immersed in an organic solvent to get the pre-debinded brown part. The residual binder is removed in the furnace prior to sintering to get the full metal or ceramic part. Using this binder system means relying on 30 years of history of use. Filament printing is clean. There is no handling of powder before, during, or after printing. Stability of the printed green part is by far better than anything you have ever seen in binder jetting. Printing hollow structures or cavities? Do it! You generated green part scrap or support structures? Don't worry, just grind and print again. This is truly sustainable. Prototyping and small series production by filament printing and large series of 10,000s of parts by powder injection molding using one binder system. Be fascinated, be curious, explore the possibilities. Contact us any place, anytime to join us on our journey.